Good afternoon, everyone. My name is Jeff, and I'll be speaking to you about some of the self-discovery and explorations into the iterative design process that I had in the last 8 weeks. So we began in Rhino, where we hardly knew any commands, could barely draw lines or even rotate the screen properly. And we were told of the iterative design process where we repeated same steps, but just changing one variable at a time so that we were influencing our design in an understandable way. And we carried that over into NURB surfaces, where we turned on the control points and we started pushing and pulling certain things, but again, one step at a time so that we can understand how our form is changing from the original based on what we were doing. And then we were told to do something with planes, so with a growing knowledge of pushing and pulling control points, we were able to create something that resembled the plane. And from there on, we explored how we could actually recreate this in the physical world. And of course, we can go with the standard presets of parallel toolpaths or even the familiar contour cut paths there. But that runs counter to what we've been doing the whole time, which is not to throw on a standard process onto our design without understanding what exactly it's doing for our plane. So we went into the custom toolpaths from line geometries, and we partnered up with a friend to see if we can mill both the top and the bottom side of the airplane by a good understanding of exactly what we were doing. And we were successful in doing that. We had our own custom toolpaths, and we created the foam planes, and we understood based on the material type, the tool bit, the time spent, etc. These variables that we were able to adjust one at a time from our iterative or repetitive process. And we moved into the realm of laser cutting from there. I cleaned up my original NURB surface by with a gesture towards the landing and taking off of airplanes here, so that I had a cleaner surface that is approximated by 2D triangle geometries, which we know is definitely cuttable on the laser cutter. But in further developing my design, I lost track because I made the mistake of attempting to adjust everything at once without truly understanding the effects of what I'm doing actually to my overall design. And so I looked towards outside inspirations, and I came across this cloud, or what seemed like a digital or digitized or pixelated version of a cloud. And I thought, well, clouds are usually formless, so how are they able to capture that? And I saw that there was an understandable triangle geometry that I outlined here, and they were able to take that and apply it repeatedly throughout. And so I thought, well, I'm going to do that with my cloud and somehow create a rolling cloud form that is still laser cuttable. And I took a small chunk and began working on that, and I applied it, and it worked rather nicely for the front portion. However, despite the smaller modules being well tested, when I applied to the overall system, there were some problems that there were some gaps in the system, and that just reminded me that there was always further refinement needed. And so here's a important video of the command. So I began with a module of my on my plane, and as you can see, there are flattenable 2D geometries of triangles, and I just thought, well, why not start with just control point curves, just simple curves that would gesture towards the smooth and the free form of a cloud. And as you can see, next I trimmed the curves, or split it. And then the command here, extrude curve to point, was important because from the way I was creating these curves one at a time, or these surfaces one at a time, I know that they had a single iso curve, which means that these surfaces only had a single curvature, and it's not a double curvature surface that would be unflattenable and therefore uncuttable on the laser cutter.